So number 19, again, we're just trying to find the extreme values of the function. And we already know a couple things about this function. At least we should be thinking about this in terms of, all right, well, we know that the function is a parabola, a quadratic function, and we know the shape of the graph of a quadratic function is a parabola. And we don't really know where the vertex is yet. We could easily find that by doing negative b over 2a. And why don't we go ahead and do that anyway, just to make sure we know where it's at. Negative b would be negative 8 over 2a, which is 2 times 2. And so we get 8 over 4, and 8 over 4 is 2. And if we wanted to, we could figure out what the y-coordinate of the vertex is, but we don't really need that. What we really do need to know is, or we're concerned about, I guess, would be that the vertex is somewhere when x is equal to 2. We don't even care really how high or low this function is. What we do know, though, is that y is decreasing, or y prime is negative, on the interval from negative infinity all the way to 2. And we know that y prime is positive on the interval from 2 to positive infinity, and y prime equals 0 when at x equals 2. So these are the things we know without even doing really any calculus. And we need to know calculus, obviously, to know the derivatives, but we don't need to do any calculus to get this. We've already been able to graph the quadratic functions, and by doing that we could easily know how to answer this question, where, in other words, where y prime is positive, y prime is negative, and extreme values, we would have an absolute min at x equals 2. So we can see the graph, we know that, but I wanted to walk you through how to find our absolute max and absolute min by using the calculus that we've learned, because it's not always going to be that easy to graph the particular function. So we're going to go ahead and do this. I'm going to write down right here y equals 2x squared minus 8x plus 9, and then from y we're going to figure out what y prime is. So we're going to take the derivative of this function, and the derivative of the first term is 4x, the derivative of the second term is negative 8, and the derivative of the third term is 0. Well, remember where critical points happen. If we remember from the last slide, we know that critical points happen, let's see, the slide before that, critical points happen where f prime is equal to 0 and f prime does not exist. And so if we want to find our critical points, that's our step 1, find critical points. Okay, well, y prime, let me do this in a different color. Y prime is equal to 0 when 4x minus 8 is equal to 0. Well, we know where 4x minus 8 is equal to 0 because we can just solve the equation for x, and if we add 8 to both sides and divide both sides by 4, we get that x is equal to 2. So when x is equal to 2, we have a critical point. Okay, that's our only critical point. Only critical point. Okay, well, if it's our only critical point, then it's the only place where we might possibly have a max or a min. And keep in mind, we haven't seen any of this yet, but keep in mind, though, that just because we have a critical point doesn't mean we have a max or a min. All it means is that we might have a max or a min. Well, what has to happen at that critical point? Well, that's a good question. What has to happen at that critical point is that f prime has to change from positive to negative or from negative to positive. And if it changes sign, then we have a max or a min. Well, let's go ahead and test this out. F prime at 1, because 1 is to the left of 2, and so we're going to test f prime at a value of x to the left of 2. And f prime to the left of 2, f prime of 1 would be 4 minus 8, and 4 minus 8 is a negative number. Okay, negative 4. So if f prime of 1 is negative, that means that f prime of 1.5 would be negative, 1.6, 1.8, 1.9. F prime of 0, f prime of any negative number is going to be negative. And so because of that, I'm going to put these little minus signs here in this interval, indicating that f prime is always negative on the interval from negative infinity all the way to 2. Keep in mind that we already knew this to be true because of the graph that we drew in the beginning. Okay? Well, likewise, we're going to need to figure out what the derivative of f is, what the sign of the derivative, or the sign of f prime is, on the interval from 2 to infinity. Well, that means we have to pick a test value, and let's pick a test value of 5. Okay, f prime of 5, and when we plug in or substitute 5 for x, we get 4 times 5, which is 20, minus 8, which is going to give us a positive number. Okay, so just like when we tested the value of x to the left of 2, now we're testing the value of x to the right of 2. And testing any value to the right of 2 is going to yield f prime being positive. Well, if you remember what that connection means is when f prime is positive, it means that f is increasing. Okay? So when f prime is positive, f is increasing. When f prime is negative, f is decreasing. I'll just abbreviate decreasing. And then again, on the interval from 2 to infinity, f is increasing, f being decreasing before 2, coming down like that, f increasing to the right of 2, and for the reason that f prime, so we can say, I'll go ahead and summarize this whole thing here, therefore, since f prime changes from f prime being negative to f prime being positive at x equals, hold on, I got a phone call here. I don't remember exactly what I was saying, but probably I was saying exactly what I wrote down here before I paused the video. I had to pause that. Since f prime changes from f prime less than 0 to f prime greater than 0 at x equals 2, we have a local, I should say that f has a local min at x equals 2. Now, you might be saying, well, why don't we call it an absolute min? Well, I am going to call it an absolute min. I just want you to understand that just because it changes sign, f prime, just because f prime changes sign from negative to positive at a particular x value doesn't mean it's an absolute min, okay? It doesn't make it an absolute. What makes it an absolute, and this is a key concept here, and you'll use this more in calculus, but since f prime is always negative, or you know what, I think it would be better. It would be better to say it like this. Since f prime of x is less than 0 on the interval from negative infinity to 2, and f prime is positive on the interval from 2 to infinity, therefore it's always negative until you get to 2, and always positive from 2 to infinity, f has an absolute max at x equals 2. Now, we can easily find what that absolute max is, or sorry, did I say max? Shoot. I said max, but I meant min. I hope you caught that. Absolute min. Because if we go from f prime negative to f prime positive, that's a min. Yeah, so let's not forget that part. Anyway, on this last part here, I'm going to take this section right here, and we can easily determine what the value of the function is when x is equal to 2. So we might as well go ahead and do that. Y of 2 equals 2 times 2 squared minus 8 times 2 plus 9. And so 2 times 2 squared is 2 times 4, which is 8, minus 16 plus 9. I like to add the 8 and the 9 first and get 17. 17 minus 16, and that's 1. And so what we actually have is an absolute max of 1, absolute I keep saying max, an absolute min of 1 at x equals 2. So that's I realized that I took a long time to talk about that and to actually show what that is, but this is the basis of understanding that you need to have in order to be successful in curve sketching in calculus. This is always what you can go back to as being your basic level of understanding and the basic components of a problem in which you need to figure out where f has a maximum value or a minimum value. I know you're not going to realize how important this concept really is yet, but trust me that these concepts are super important when you get into calculus, because it really doesn't matter what kind of a function you're dealing with. The basic components of determining whether f has a max or a min is a central concept in the study of calculus, and it is very, very important that you get this down and that you don't forget the basics, because when you understand the basics, the rest of it is really just algebra, and you'll see that. You'll struggle if you struggle with algebra in this area, and if you don't struggle with algebra, you'll do really well. But nevertheless, it's the calculus concept remains exactly the same. When f prime changes sign, you're either going to have a max or a min, and I hope you take heed my advice here, I guess, in that how important these concepts are. So I'm going to go ahead and stop this recording, and I'll finish up my third video. We'll show you how to do problems 45 through 48.